Hi gents, what we're going to do today is we'll do a couple of questions that got sent in by some of you. So I think Jude, thank you for confirming this is the right question there, Jude, asked to try this one out. So it's 2012, it's paper 1 and it's question 6. I was just confirming it was the right one because that was a year of transition for project maths. So there were some... there was one paper for some group of students and a different paper for others. So just confirming that that's the case. Anyway, this is the one that we'll do. It says a group of 4 students is studying graphs of functions in the form y equals, we can call that if we want to, x squared plus 2x plus k. Each takes an integer value of k, so what's that, a whole number value, puts it in for k, and draws the graph of their function in a suitable domain. Maria took k equals -8 and drew the graph below. So use the graph to write down the roots. So the roots are the solutions, okay? And it's what x equals when y is 0, okay? So it's really just, you know, if we were to make that 0, it would be x squared plus 2x minus 8. So what you could do here is you could go and solve it. Now they specifically don't want you to do that because they said use the graph, but you know, we'll just cheekily do it here. You could do this in the exam. I just do it on a sheet of paper well away from it. And what we'll be looking at, we'll be looking at +4 and -2, and so we get the answer then that x plus 4 equals 0, so x is -4. And x minus 2 is 0, so x is 2. But if you're using the graph, you should know that that is where solutions or the roots where it crosses the x-axis, i.e. where y is 0. So we would just look at that and we would say it occurs when x is -4 and when x is 2. So nice and easy. Okay. Speaking of crossing axes, just something to point out, it's probably going to become relevant during it, is that if this is the start of if this is our equation here, plus k, where something crosses the y-axis, okay, you know, if you had a line and a cross there, you would be quite sure that the x value would be 0. You wouldn't know what the y value is. I mean, we could just read it off. Here again, x is 0. So where something crosses the y-axis, x is 0. So you just get instantly y equals 0 squared plus 2 times 0 plus k. So the y value where it crosses at 0 and y, where it crosses the axis, is given by 0k. So if, was it Maria? Yeah, if Maria took k to be -8, we know that 0 minus 8 is on the graph, and indeed that is exactly where it is. So depending on which value of k you pick, it's going to cross the axes at a different place. So she's picked -8, that's why it crosses there. Okay, Keith's graph passes through the point 3, 2. Find the value that Keith used. I'll just make a little point on this one. If it says use the graph, you actually have to indicate on the graph, like draw that little dot and maybe even just draw a big circle around it like that, just saying, look, I really did show it. Okay, Keith's graph passes through the point 3, 2. Find the value of k that Keith used. Well, what do we know about the function? We know that it is y is equal to x squared plus 2x plus k. And what have we been given? We've been given an x value and a y value. So if we just sub those in, the only thing that we won't know is k, and we can solve it. So 2 is equal to 3 squared plus 2 times 3 plus k. So we get 2 is equal to 9, added to 6, added to k. So we have 2 is equal to 15 plus k, subtract 15 from both sides. K is equal to -13. Okay. It says on Alice's graph, the 2 roots of the function are the same. That's the same as each other. Okay. Could have been a little bit clearer. As each other. Find the value of k that Alice used. Okay, so let's see about this. So I know loads of ways to get the right answer here, but I'm just trying to think what would be the sort of one that will work out for you in order to get this. Maybe think of it like this. Okay, just think of it like this. If you remember, if you were given the correct answer, okay, remember. Okay, for this one, we had x equals -4 and we had x equals 2. There are a few ways to do this question, but it would mean that you would be multiplying x plus 4 times x minus 2 in order to get your y equals x squared plus 2x plus k. And if we multiply this out, we would get x squared, you get plus 4x, minus 2x and minus 8 in whatever order you want to do it. So we would end up with the right thing here. So now what you know is you'd know that k is -8. Now, think about what our solutions are for this one. All they've said is they have to be the same. Okay, so it would be x equals, now we'll just give it a name. So let's, I don't know, we'll call it, sure, we've called it Steve in the past. We'll call it Steve now. And the other solution is, of course, still Steve. Remember, Steve is just a number. What would be in our bracket? It would be x minus Steve times x minus Steve. And if we were multiplying it out, we would get x squared minus x Steve minus another x Steve plus Steve squared. Course. Okay, now just, I know we've kind of been funny using this, but if Steve's a number, so like if it's minus 7x minus 7x, it's minus 14x. So if it's minus Steve x, it's minus 2 Steve x's. Okay, minus 2 Steve x's plus Steve squared. Okay, now compare that to what we started with, which was x squared plus 2x plus k. That's what we started with. What does this mean now? Well, x squared is x squared, but it means that if those two things are the same as each other, and they are, minus 2 Steve x's have to be 2x's, so it means that minus 2 times Steve has to equal to 2 if we divided both sides by x. Well, minus 2 times what is 2? Or you could divide both sides by minus 2. That would be a way to get it. So Steve is equal to minus 1. Okay, and it tells us, therefore, that since k is equal to Steve squared, k is minus 1 squared. So k is just 1. Okay, and what you can do is you can check that. You can say y squared equals x squared plus 2x plus 1, and you'll notice that when you factorize it, you get plus 1 and plus 1. So we get the same answer. We get x equals minus 1 and x equals minus 1. There it is. And remember what we said? X is Steve, and we also said that Steve is minus 1. And so we're getting that x equals minus 1. So the whole thing makes sense there. So that's one way in which you could go and do it. Okay, so I think that's a good way to do it. I'll call it P rather than Steve, just to be a little bit boring. So we get x minus P times x minus P. This is our function. Multiply it out, x squared minus xp plus p squared. So y is equal to x squared minus 2px, we'll call it, plus p squared. And comparing it to what we started with, x squared plus 2x plus k. We can say when we compare these, x squared is with x squared, that's fine. We can say that minus 2px has to equal to 2x, divide both sides by x. Minus 2p is 2, divide both sides by minus 2, p is equal to minus 1. And since p squared is k, minus 1 squared is k, and k is 1. So Alice picked a value of 1. Tricky enough question. Okay, tricky enough question. It asks you to draw the function, does it? Yeah, sketch the function of, draw a sketch of Alice's function on the diagram. Okay, now remember what we said about k. k is, if you have y equals x squared plus 2x plus k, if you've got y equals x squared plus 2x plus 1, it means that when x is 0, y is 1. So we know that that is a point on it. When x is 0, y is 1. When x is 0, y is 1. That is a point on the graph. Okay, we also know that the solution is -1. So the solution, x is -1 when y is 0. So it goes through there. And it's symmetrical, okay? It's symmetrical. So what it should do is it should look like that and go straight up. So that is what Alice's graph should look like. Okay, why do we know that it doesn't, like, you know, do that? Okay, well, that was horrible, but yeah, this. Why is it not that? Because this would give you 2 roots, and Alice only has, sorry, it will give you 2 different roots, and Alice's 2 roots are the exact same root. Okay, so what it does is it's a quadratic that goes down, hits -1, and comes directly back up, also known as a repeated root. So there we go, we've sketched that graph. Emma's graph shows the roots of her function are -5, x equals -5, and x equals 3. So her brackets must be x plus 3 times x minus 3. So we'll multiply that out, x squared minus 3x plus 5x minus 15, x squared plus 2x, which is what we wanted, minus 15. There we have it. Okay, what k value did she use? She used k equals minus 15. That's our answer. Okay, that's a really good question. Lots of tough things going on there, and if you want to now go back over it and give it a shot, I think that's a really good one to practice your quadratics with. Okay, I'm just going to pause it here and get on to some more questions that people have sent on. Okay, we're going to have a look at this. Benjamin was just asking if we might do a little sequences and series question. Okay, so investigate whether a pattern in the table below is linear, quadratic, or exponential. So we'll just mention each thing as we go along. So we'll just give an example. Okay, an example of a linear pattern. That's just the same number being added on every time. So T1, we call it term 1, T2, T3, T4, etc. So we'll write linear here. Okay, so you can start with anything like, I don't know, 5. And we'll add the same number on each time. So we'll add on 2 each time, 7, 9, 11. Okay, simple as that. How do you check whether the thing is linear or not? What you just do is you just see, is the first difference, what's called the first difference, the same each time. Okay, and in this case, the first difference is the same each time. Therefore, you are dealing with a linear function. Okay, I was teaching you some advanced things, but it's been a while. See, can you remember what T of n is? T of n means the general term. It's going to have something with an n on it. I'll give you an example. We'll say, I'll give you the wrong one, 3n plus 2. Here's an example. What that means is when you place 1 into the function, you should get T1. So when we place 1 into the function, into that, it is a function really, we get 5. Okay, you're replacing n with 1. And that is the right answer. So, oh yeah, this must be the right thing, except it's not. T2, you should get the second function by placing 2 in for n. And here we get 3 times 2 plus 2, so you would end up with 8. So actually, we were meant to have 7, so that is the wrong function, or the wrong general term. So the question is, what is the right general term? Okay, and it's been a while, so maybe you don't remember, but what you're meant to do is for linear functions, just for linear functions, to find that general term, what you go and do is you look at what am I adding on each time. That's how many n's you have. Because every time you increase n by 1, the overall thing increases by 2. So if you know what I mean, if n is 3, you get 6 into that thing, but if n is 4, i.e. we increase n by 1, the whole thing increases by 2. And since in this case, every time we increase n by 1, we're going up by 2, it's got to have a 2n in it. So we know that it has a 2n in it. We also know that t1 is 5, i.e. replacing n with 1 is 5. Well, if we replace n with 1 here, we get 2. We're meant to have got 5. That tells us we should add on 3. So it'll be 2n plus 3. Not required for this question, as it turns out, but I just want you to be able to do it on the more tricky ones. Okay, that's an example of a linear function. What we'll do now is we'll take a quadratic function. Okay, so with a quadratic function, what we'll do is, well, you can start with anything that you want. In fact, let's just we'll make a quadratic function. So we'll say n squared plus 2n plus 3. Okay, so what would t1 be? Just figuring out. So when you place 1 in there, we'll get 1 plus 2 plus 3, we'll get 6. All good. What will t2 be? So 2 squared, that's 4, plus 2 by 2, 4, plus 3. So this is going to be 11. T3 is 9 plus 6 plus 3. That seems to me like it's 18. T4, thank God I didn't go any higher, is 16 plus 8 plus 3. So it's that 27, I think. I better double check that one. 24, yeah, 27. Okay. So this is going to be an example, and we'll pretend that we didn't know this thing before. Let's just say we were given this. So the first thing we would try to see is it linear? Okay, and the way in which you check is it linear, you just do first difference. And here you'd see, what do I have to add on? I have to add on 5. But here I have to add on 7. And here I have to add on 9. It's not the same thing. So the first difference is not the same. If it's not the same, it's not linear. But if the second difference is the same, and it is, if the second difference is the same, you're dealing with, and it is, yeah, we're dealing with a quadratic. Okay, so that's what you would be dealing with. Okay, simple as that, to be honest. Okay, how would you get the quadratic function? Okay, this is what you would do if you remember. So the first thing is we'll write it out as the general term ax squared or an squared. They often use that, plus bn plus c. Okay. So what it is, the second difference, just memorize this one, second difference divided by 2, that's a. So our second difference here is 2 divided by 2, that's our a value. So we have tn is equal to 1n squared. Okay, that's fine. What now? Well, the t0, if you were to replace n with 0, you would end up getting 0 plus 0. T of 0 equals 0 plus 0 plus c. So you just get t of 0 as the c value. So if you can go back a stage, if you can go back here, get rid of this. If you can go back a stage, now remember what's being added on each time. So this should be plus what, okay, as we do that. Well, what were we going backwards in 2's with? Well, what it said was it was plus 5, and then we added 2 onto it to make plus 7. So this must have been plus 3. So 3 must have been added on, and if 3 was added on, it must have been 3 to begin with. So we know that t0, which is c, t0 is 3. So we can say straight away that c is 3. Okay, so far so good. Now we just have to use our old trick of placing in t1. So t1, which is 6, and we're placing in n equals 1. Remember, that's what we're replacing with. And we get an squared, so a was 1. So we just get 1 times 1 squared. It's b times 1, and it's plus c, which is 3, and that should be 6. So 1 squared is 1, and 1 times 1 is 1. So 1 plus b plus 3. So we get 6 is equal to 4 plus b, subtract 4 from both sides, b is 2. And now we can say with certainty Tn is equal to a, which is 1, times n squared plus b, which is 2, 2n plus c, which was 3. And we remember that that was what we started with. So that's how you get it. It's a lovely little fast way to get it. But quadratic, it's all about seeing, is the second difference the same, not the first. Okay, and an exponential is totally different to all of those. An exponential, which we've been hearing so much about, is this. It is something like, 2 to the power of x. We'll call it a to the power of x. We'll just make a little table of that. Okay, y equals, so we have our input and our output. So our input might be x, our output would be y. So we place 0 in, we get 2 to the power of 0, which is 1. When we place 1 in, we get 2. When we place 2 in, we get 4. When we place 3 in, we get 8. 2 cubed, 8. 16, and you can see it's doubling each time. Okay, because every time you increase n by 1, or x by 1, what you're doing is, if you go from 2 cubed to 2 to the 4, you're taking the previous answer, which is 2 by 2 by 2, and now it's 2 by 2 by 2, except by 2 again, so it's being doubled. Okay, and that's obviously going to continue the whole way along. So that is what it looks like. What will it do? First difference, plus 1, plus 2, plus 4, plus 8. Okay, so not the same, not linear. Second difference, plus 1, plus 2, plus 4, not the same either. Okay, but I think you might be able to see the pattern that's in there. That's plus 16, that's plus 8. Oh, look at that. Okay, what if we were to take the third difference? We'd get plus 1, plus 2, plus 4. Look at that. Okay, so that's what an exponential is. Okay, basically what you're just looking for is you're looking there that that the first difference and the second difference isn't going to be the same. It's a good starter for you. But yeah, it's just multiplying by itself each time. Okay, in this case, investigate whether the pattern below is linear or quadratic or exponential. Explain your conclusion. Well, that's, of course, our test is to get the first difference. What do we add on to go from there to there? We have to add on 6a's, and we have to add on a minus b, or you can just say we're taking b away from it. Okay, you can do that. That's our first difference. Okay, to go from here to here, we have to add on 10a's, and we need to take away a single b. So first thing, is it linear? Not linear, because that is different to what it was before. We'll just keep doing that just for a quick little second here. So what are we, what are we adding on? We're adding on 14a's, 14a's, and we're taking away a b. And here we are adding on, what's that, 18a's and taking away a b. Okay, so not linear, is it? Quadratic. Is the second difference the same? Well, what do I add on to go from there to there? Well, I add on 4a's. To go from there to there, what do I add on? I add on 4a's. And from there, 4a's. Yeah, absolutely. So what would I write here? I would say this is quadratic. Because, did ask you to explain, because the second difference is the same. Okay. We'd want to do, like that wouldn't be acceptable as a leaving cert answer, just to say, it's not a proof. You haven't absolutely proven it. What we've just done is we've just gathered some evidence. You could find an exponential, perhaps that looks like a quadratic for the first couple of terms, I'm sure. But there you go. That is what you would say for it. So those are two good questions. Just to go back over both quadratics, functions, and a bit of patterns. What I'm just going to do now is I'm just going to pause and suggest a couple of questions for you to try. Well, as it turns out, the next question is directly below it, which I like it. So this is 2013, it's paper 1, and this is question 15. So this is one that I think that you should try. I have a feeling that this cropped up on maybe a second year exam. I have a feeling that we did it there. There are 3 functions as defined below, and here they give you a chance to solve. So they're just asking you to solve a quadratic. F of x is 0, so just solve that quadratic, solve this quadratic, and solve that quadratic along there. Okay, they're all solved in slightly different ways, and just as a small hint, you do not have to use the quadratic formula. Okay, don't have to use the quadratic formula, just very simple factorization will do. Okay, thanks, gents. All the best.